Peterson, do you have something you'd like to mention?
Yes. First, I'd like to welcome the House of Representatives House Science, Space, and Technology Committee. It's an honor to have you in our city, and it really is great that you are looking from a federal level at our region. I mean, as municipal leaders, county leaders in this region, we all know about earthquakes, and to have the federal government look into this and really know what we bring to the table. Billions of dollars of goods come through our ports in this region to the rest of the country. And to have you have your field hearing here is wonderful for our city, and I hope while you stay here, you enjoy our beautiful city and our coastline, and take Congressman Roy Barker out and take you out surfing if you need to. Thank you very much for having the hearing here. Enjoy yourselves, and thank you for all your support for our region.
Thank you very much, Mayor Peterson. So, the Committee on Science, Space, and Technology will come to order. Without objection, the Chair is authorized to declare a recess of the committee at any time. Hearing none. Good morning and welcome to today's hearing entitled Earthquake Mitigation, Reauthorizing the National Earthquake Hazards Reduction Program. And I recognize myself for 5 minutes for an opening statement. All right. And again, welcome to my colleagues to Huntington Beach. I'm very pleased that you both came today. It's my honor, of course, to welcome you to Surf City, USA, but also the city that I might add was the city where we built the first stage of the Saturn rocket that took the first human beings to the moon. And we're very proud of our beach culture. We're very proud of our aviation and our space achievements. I'm glad that two of my colleagues have been able to join us today. Representative Mark Takano, pardon me, I say that all the time, and Jerry McNerney. Both are really been very active with me over the years, and actually we have very positive personal relationships with each other. And I think that demonstrates the type of cooperation that we want to see in Congress and is exemplified by the Science Committee. In California, at any moment, we know this, that we could face a really big earthquake. Not just a little shaker, but a big earthquake. It's something that we can get complacent about because it always seems to be in the future that might happen, and then when it doesn't, we get complacent. Well, the risk is very real. According to the USGS, California has a 99% chance of experiencing a magnitude 6.7 or larger earthquake over the next 30 years. The likelihood of an even larger earthquake with a magnitude 7.5 or greater is 46%, and such an earthquake would likely occur in the southern part of California. So this is a major threat that we need to look at. But California, of course, is not alone when it comes to this. Close to 75 million people in 39 states face some risk of an earthquake. For 40 years, the National Earthquake Hazards Reduction Program, now I'm going to have to be reminded, how do we pronounce that? NEHRP. Okay, now I know how to say it. NEHRP has supported efforts to assess and monitor earthquake hazards and risks here in the United States. 4 federal agencies coordinate their earthquake activities under NEHRP. U.S. Geological Survey, National Science Foundation, Federal Emergency Management Agency, and the National Institute of Standards and Technology. These agencies assess U.S. earthquake hazards, delivery notifications for seismic events, develop measures to reduce earthquake hazards, and conduct research to help reduce the overall U.S. vulnerability to earthquakes. Congress has last reviewed and reauthorized program in 2004, and that law expired in 2009. Although Congress continues, however, to appropriate funds for this important work, we are long overdue to reauthorizing this program. We must ensure it is effective and up to date with the latest knowledge and science for monitoring and mitigation of earthquakes. I am particularly interested in how we can improve the use of data to advance the deployment of an effective earthquake early warning system. I'll be very interested in hearing if that's even possible and to what degree we could use this as a goal. Such a system would automatically send an alert to areas in danger of potential shaking after the earthquake hasn't been initially triggered. The alert would potentially allow components of lifeline infrastructure such as electric utilities, railroad systems, even hospital operating rooms to cease activity that could be impaired by a violent shaking before the first earthquake-triggered surface waves actually reach them. So we know that Senators Dianne Feinstein, Lisa Murkowski have introduced bipartisan legislation to reauthorize this agency and this operation. And they have that in the Senate, and I will be working with my Science Committee colleagues to introduce a bill in the House very soon for this reauthorization. I thank my witnesses for being here today. Look forward to your expert testimony, and maybe we have an opening statement by, I'm not going to mispronounce your name after I've been talking to you for a decade now, Takono.
That's right. Thank you.
There you go.
Well, I want to welcome everyone to today's hearing. I just want to make sure that the live stream is functioning. I got some reports that it wasn't working on the science website yet, the Science Committee website. Somehow I just put my chair down to the bottom.
That way.
To bring me down, bring me down to size. I want to welcome everyone to today's hearing to review the nation's foremost earthquake research and risk mitigation activities under the National Earthquake Hazard Reduction Program, otherwise known as NEHRP. I look forward to our expert panel, the expert panel's assessment of the program's strengths, weaknesses, and challenges and recommendations for improvements. As an Inland Empire native, I'm all too familiar with the damage that can be caused by earthquakes. Just this month, the Riverside area experienced a 4.5 earthquake followed by 2 smaller earthquakes. And while there are no reports of injuries or damage, it reminds us that we need continued strong support of our federal earthquake risk mitigation activities. Now, I am proud to recognize in the audience Dr. David Oglesby. Dr. Oglesby is raising his hand in the back there. Let the record show that. And Dr. Christos, now I've got a more difficult name than my name, Mr. Chairman. Kyriakopoulos. 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 Okay. Of the University of California, Riverside. And they're both in the audience today, and they're from my district. Set up on display way over in the back of the City Council chambers is a 3D printed representation of the fault lines in the state of California that my university produced. And I have a smaller version of it, and people think that the faults are just one, maybe just one spine, but really you can see that it's a really an amazing amalgamation of faults. And to know that here is LA and here's Huntington Beach, San Diego, and Riverside, you can see we're like sitting on top of numerous faults that come together. And Mr. Chairman, I want to let you know that the university has been so kind as to produce one of these for you and for Representative McNerney. And I hope that we can get one to each one of the members of our delegation.
But we'll keep it on the wall unless it falls down in the earthquake.
But I think it will raise awareness of just how much we need to keep our eye on the ball. We struggle with how to encourage cities and regions in high earthquake risk areas to implement mitigation measures. But I have a feeling that these kinds of demonstrations might help. We can't forget the importance of social and behavioral aspects of earthquake risk mitigation, and I encourage everyone to take a look at the display, the big display at the end of the hearing. Following the devastating earthquakes in Alaska and California in 1964 and 1971, Congress established NEHRP and tasked 4 agencies: the National Science Foundation, the U.S. Geological Survey, the Federal Emergency Management Agency, otherwise known as FEMA, and the National Institute of Standards and Technology, otherwise known as NIST. And NIST was tasked as being the lead agency to reduce the risks to life and property from future earthquakes. Now, the good work of these agencies and their public and private sector partners has advanced the nation's understanding of earthquakes and provided the science that supports seismic design guidelines and standards for resilient buildings that save countless lives. Unfortunately, economic damages are still very high after extreme natural hazards, and it is important to invest in community resilience. Resilient lifelines such as roadways, pipelines, power lines, and communications infrastructure can help get communities back up and running sooner after a big earthquake. In fact, the National Institute of Building Sciences recently released National Hazard Mitigation Saves 2017 interim report. It's a document, and it found that for every $1 spent on hazard mitigation, the nation saves $6 in disaster costs. Though the West Coast is widely known for its earthquake risk, the U.S. seismic hazard maps show that the central and eastern parts of the nation, as well as Puerto Rico and the U.S. Virgin Islands, are also categorized as having a high probability for strong earthquakes. 200 years ago, the New Madrid seismic zone in the middle of our country endured 3 7.0 or higher earthquakes. Further, the composition of the earth under these regions allows the impact of an earthquake to be felt several times the distance as an earthquake on the West Coast. Now, while several countries in seismic-prone areas have had earthquake early warning systems for many years, the U.S. continues to develop and implement pilot programs for the West Coast for a West Coast early alert system. I look forward to hearing from our panel today about what Congress can do to accelerate and eventually expand deployment of this life-saving technology that can provide seconds to tens of seconds of time to stop surgeries, that could stop surgeries, keep airplanes in the air, and shut down nuclear power plants and other sensitive machinery. I also believe it's important that we better understand the current state of our infrastructure and buildings and how retrofitting can mitigate both the loss of life and the cost of rebuilding after an earthquake. These issues are so very important to regions across the nation, and I thank the panel for their testimony before this committee, and as this committee considers legislative priorities for NEHRP authorization. Thank you, and I yield back, Mr. Chairman.
Thank you, Congressman Takano, and now Congressman McNerney.
Well, I thank the chairman, my friend from Huntington Beach, for calling this hearing. I thank the panelists for coming, and I'm looking forward to your hearing. My district is a little north of here. It's in the Delta region of California, so we have the confluence of the San Joaquin River and the Sacramento rivers forming the California Delta. It's got an extensive system of levees. Many are very aged, so we're very concerned. The governor has a plan to put in tunnels, and we need to understand what the seismic risks of that project may be. But in all, we see damage, and when we have earthquakes, and it's so important to have a set of very good standards that mitigate or help us mitigate the damage. For example, we've seen in other countries in the last half century, earthquakes of a magnitude of 4 to 5 have caused immense damage and thousands of deaths. Whereas in this country, we've had earthquakes in the order of magnitude of 7 on the Richter scale, and we've seen tragic damage, but nothing on the scale that we've seen overseas. So these standards are very, very important to the health and safety and economic well-being of our communities and our country. So that's why NEHRP's mission is so important, and we want to make sure we understand what sort of objectives are realistic with your mission, with NEHRP's mission, and how we can attain those objectives, how much it's going to cost, and so on. So I welcome your testimony, and I look forward to the back and forth afterwards. Thank you, Mr. Chairman.
Thank you, Congressman McNerney. This is a very serious issue today. This is very serious because we know that this potential dangerous situation is hanging right there. It could happen tomorrow, and it could happen 10 years from now or 100 years from now, but we know it could happen tomorrow, and we need to make sure we're prepared, and I appreciate my two colleagues joining us today, and I appreciate the witnesses that we have. We have first-class witnesses to help us understand the threat and how we should move forward if there are ways to move forward to mitigate this challenge. I will introduce the witnesses, and then we will start. First witness today is Dr. Stephen McCabe, Director of the National Earthquake Hazard Reduction Program. And let me note that the leader of the Earthquake Engineering Group, he's also there with NIST. McCabe has received both his Bachelor's of Science and Master's of Science in Mechanical Engineering from Colorado State University. He also earned a PhD in Civil Engineering from the University of Illinois at Urbana-Champaign. Dr. Stephen Hickman, our second witness today, is Director of the U.S. Geological Survey Earthquake Science Center in Menlo Park. Dr. Hickman received a bachelor's degree in geology from Earlham College, as well as a PhD in solid earth geophysics from MIT. And then Dr. Frank Vernon, our third witness today. He is a research geophysicist at the Institute of Geophysics and Planetary Physics at the Scripps Institute of Oceanography at the University of California at San Diego. Boy, that's a mouthful. He is also the director for the U.S. Array Network Facility for the NSF Earth Scope program. And Dr. Vernon received a BA in physics from the UC San Diego and a PhD in earth science from Scripps Institute of Oceanography. We also have with us Chris Poland, our fourth witness. He is a consultant engineer and a NIST Community Resilience Fellow. He previously served as chairman of NEHRP and on the NEHRP Advisory Committee. Mr. Poland earned his Bachelor's of Science in Mathematics from the University of Redlands and his Master's in Science in Structural Engineering from Stanford University. Our final witness today is Mr. Ryan Arba, a branch chief of the Earthquake and Tsunami Program in the California Governor's Office of Emergency Services. He oversees the state's preparedness efforts for seismic events. Mr. Arba received a degree in social and behavioral sciences from Cal State Monterey Bay and a master in public administration from a degree in that from the University of Southern California. I now recognize, and I would suggest that if we keep it down to 5 minutes apiece, we then will have a dialogue, which is what this hearing was intended. So I now recognize Dr. McCabe for 5 minutes to present his testimony.
Thank you. Chairman Rohrabacher, Congressman Takano, Congressman McNerney, I'm Dr. Stephen McCabe, the Director of the National Earthquake Hazard Reduction Program, or NEHRP. Thank you for the opportunity to appear before you today to discuss NIST's role in reducing the earthquake risk facing U.S. communities. NIST is the lead agency in the four-agency partnership that is NEHRP. The Federal Emergency Management Agency, the National Science Foundation, and the U.S. Geological Survey are our other three partners. Earthquake concerns are truly national in scope. 42 states and a number of territories face serious risk from earthquakes. The 1971 San Fernando earthquake caused serious damage and was a motivating factor for the creation of NEHRP. More recently, there have been significant increases in seismic activity in southern Kansas and in Oklahoma. There are simply no areas of the nation with zero risk from earthquakes. Mitigation efforts through such measures as improved building codes can make a significant difference in saving lives, which is the primary goal of earthquake-related provisions in U.S. building codes and standards. The NEHRP agencies work to perform needed research and to translate research results into actions that mitigate the impact on the nation. These include the development of national hazard models and maps, disaster investigations concerning engineering, geology, seismology, and social science aspects of an earthquake, participation in the development of model building codes and associated standards, and the funding of basic research. NIST carries out applied research to develop and deploy advances in measurement science related to earthquake engineering, including standards to enhance disaster resilience of buildings, infrastructure, and communities. NIST research has provided data to support improved codes and standards through testing of structural elements, developed improved modeling and assessment techniques for existing buildings, and assess the impact of new materials in improving seismic performance. NIST is actively collaborating with FEMA in addressing non-ductile concrete building performance, such as that noted in the Los Angeles area concerning older buildings. NSF funded initial work on this problem. In 2015, the City of Los Angeles enacted Ordinance 183893, which is a mandatory retrofit program for soft first-story wood frame buildings and non-ductile concrete buildings. Seismologist Dr. Lucy Jones, on loan from USGS, and working with the City of Los Angeles, was a key voice in this process. Thus, the enactment of this important ordinance is a result of the activity of all four NEHRP agencies in addressing this problem. Preventing collapse so that occupants could safely leave damaged buildings has been the goal inherent in building codes since their inception in 1915. However, there's been a growing call for expedited recovery from earthquake and other natural hazard events. Significant economic interruptions due to earthquake damage are no longer acceptable. NIST has initiated a large effort to aggressively study the engineering, social, economic, and policy issues concerning making communities resilient. The Community Resilience Planning Guide has been developed for use by local communities in planning their own resilient future. NIST also has funded a resilience center to provide tools for communities as they forge a resilient future. Improved building performance is another aspect of moving towards resilience. A recent study completed by NIST considered what would be required in terms of research and implementation for adoption of an immediate occupancy performance objective for building design. The concept is to improve building performance to the point that occupants would be able to quickly reoccupy business and residential buildings following a natural hazard event. NIST has worked with and looks forward to continuing to work with the House Committee on Science, Space, and Technology concerning reauthorization of NEHRP. Our challenge is to ensure that new knowledge and experience gained through NEHRP continues to be developed and applied to domestic practices and policies that foster a more resilient nation. We must keep working to mitigate the impacts of earthquakes on our communities. NEHRP is an integral part of the private-public collaboration that continues to reduce risk of damage to our communities from seismic ground motions. Thank you again for the opportunity to testify on NEHRP, and I'm happy to answer any questions that you may have.
Thank you very much for your testimony, Dr. Hickman. You have 5 minutes.
Thank you, Congressman Rohrabacher and colleagues, for inviting the USGS to this hearing. I am Steve Hickman, Director of the Earthquake Science Center. Our center has been a flagship USGS research center in the West for over 50 years. And here in Southern California, we have had an office in Pasadena for over 40 years, working closely with partners at Caltech and elsewhere. The USGS is a committed partner in NEHRP. The agencies have continued to work closely together since the Appropriations Authority for NEHRP expired in 2009. NEHRP was founded on the belief that while earthquakes are inevitable, there is much that we can do as a nation to improve safety, reduce losses and impacts, and increase our resilience. Within NEHRP, each agency performs a distinct and complementary role. The heart of this partnership is a shared commitment to translate the results of research and monitoring into actions that can reduce earthquake losses. The USGS role within NEHRP is to deliver the scientific data and information tools that engineers, emergency managers, government officials, and the public need to prevent earthquake hazards from becoming disasters. USGS activities under NEHRP are implemented through the Earthquake Hazards Program and the Global Seismographic Network. We provide rapid authoritative information on the magnitude, location, shaking intensity, and potential impacts of earthquakes, both in the U.S. and around the world. The USGS also develops national and regional hazard assessment maps and detailed scenarios forecasting the impacts of anticipated major earthquakes. And we carry out targeted research to improve these products. The USGS National Earthquake Information Center, which supports this work, is a 24/7 operation providing situational awareness for emergency responders and the public. This information is made possible by the earthquake monitoring networks that make up the Advanced National Seismic System, including regional seismic networks that the USGS supports through its academic partners. Significant improvements to the ANSS were made in 2010 and 2011. In fiscal year 2018, we are continuing this effort by directing $5 million for deferred maintenance and, according to congressional direction, $23 million for build-up of the earthquake early warning system called Shape Alert. Congress has appropriated funds in recent years to continue development of the system, and the USGS is committed to working with Congress to determine the appropriate cost share for future Shape Alert developments. Our goal is not simply to duplicate the early warning systems of other countries, but to build the most advanced earthquake warning system in the world. USGS research is supplemented by external research through grants and cooperative agreements. The Southern California Earthquake Center at the University of Southern California, supported by the USGS and NSF, is an example of such a research partnership. We have supported research projects at various academic institutions across Southern California, including Caltech, USC, UCLA, UC Irvine, and UC San Diego. In 2017, our external research funding in the region amounted to $4.5 million. All the best science, however, cannot guarantee that people are able to use the information to make informed decisions. Therefore, the USGS has supported publication of Putting Down Roots in Earthquake Country, now available for 8 different regions and in 5 languages. These and other USGS publications explain how residents can prepare for, survive, and recover from earthquakes. We have learned much about earthquakes in California and translated that knowledge into better building codes and better emergency response plans. While many critical pieces of infrastructure have been retrofitted to better withstand earthquake shaking, other infrastructure has lagged. Many seaports and some airports are built on land that is susceptible to liquefaction, where shaking causes the soil to temporarily lose strength and cohesion and flow laterally, behaving something like quicksand. Lastly, I want to remind the committee of the annual Great Shakeout, which began in 2008 as a part of a scenario for a major earthquake on the southern San Andreas Fault. This year's shakeout event happens in October on the 18th at 10 a.m. in the morning. People around the country and the world will participate in drills to practice safe responses to an earthquake. Please encourage enlisting your offices of participants at shakeout.org. In summary, the Department of the Interior supports reauthorization of NEHRP because it has been a successful interagency partnership that continues to make valuable contributions to the nation's resilience to earthquakes and other hazards. On behalf of the USGS, thank you for this opportunity to testify today.
Thank you very much for your testimony, Dr. Vernon.
Chairman Morbacker, Representative Takano, and Representative McNerney. Thank you for the opportunity to discuss a National Earthquake Hazard Reduction Program. My name is Frank Vernon. I'm the director of the U.S. Array Network Facility, which is part of the EarthScope program, and I'm work at the UC San Diego Scripps Institute of Oceanography, Institute of Geophysics and Planetary Physics. There you go. So I would also like to ask to have my written testimony entered into the record as the formal record, please.
Without objection, and that will also be true of our other witnesses as well.
Most of my career has been focused on developing distributed real-time sensor networks and autonomous sensor networks in terrestrial and marine environments. In 1982, in partnership with the USGS, we deployed the first digital seismic telemetry network in the U.S. On the San Jacinto Fault Zone here, and it's known as the ANZA Seismic Network. That network was funded by the USGS through NEHRP through its instantiation in 1982, and then with funding that continued through 2014. Another project that we've been working on is the EarthScope US Array, which is one of the primary things. The US Array is a project that is a seismological component of the EarthScope program of NSF. The core of the US Array project was known as the Transportable Array, comprised of 500 broadband seismic stations deployed at a nominal 70-kilometer grid bounded by the borders of the lower 48 states. Each station was deployed for about 2 years and rolled from a manner from the west coast to the east coast starting in 2004 and completing in 2015. After the TA completed work in the lower 48 in 2015, the project was divided into two parts. Under NSF funding was secured to deploy approximately 280 stations in the state of Alaska, and that project is slated to continue through 2019 and 2020, depending on which tier of the stations you're talking about. Approximately 160 stations deployed in the TA have been transitioned into the central and eastern U.S. seismic network, which started in 2014. SUSAN, as we call it, data streams have been integrated into the Advanced National Seismic System, the ANSS, and the operations are now being transitioned to the USGS internal operations. In my opinion, it was a missed opportunity when US Array TA was proposed that the USGS and NSF did not come up with a plan to transition all the TA sites into the ANSS permanent stations. If that had occurred, the 48 states would have approximately a 1,600 station network, nominal 70-kilometer grid, recording all earthquakes down to magnitude 1.5 with completeness for the whole lower 48 states. With the current deployment in Alaska, there's still opportunity to decide to transition the TA stations into the permanent Alaska seismic network, a key component of the ANSS. Another component of the US Array program was funded through the American Recovery and Reinvestment Act, leveraging the existing permitting field program and telemetry to augment with infrasound and meteorological sensors. And this is something that I think is very important. It's like those of us who are in the field side of things do a lot of work dealing with permits, dealing with access to sites, dealing with communications, dealing with networking, and we should be leveraging this much more broadly than we have historically done in the past. For instance, the data that we put in these meteorological sensors are now available to National Weather Service for incorporation to the forecast models. So overall, I think, and I would like to step back a bit and say that the NEHRP program has been extremely beneficial towards our understanding of earthquakes and their related hazards. The strengths of the program, the partnerships between the academic organizations, state agencies, and federal NEHRP agencies has been remarkable. Based on my experience on deploying and operating seismic networks and field experiments under NSF and USGS funding, as well as conducting research on these data, I would like to make the following recommendations. First is to keep a well-funded basic and applied NSF programs in earthquake engineering, the properties of earthquake sources, ground motion estimation, and other aspects of earthquake faulting, which will be key to make advances to understanding the earthquake hazards and earthquake risk. Second is to keep a sustainable advanced national seismic system, including support for the existing 11 regional seismic network operators. Next would be to support the research at the ANSS partner facilities that improves their ability to deliver accurate earthquake assessment and products. I mean, this is a compartment because each of these networks that operates in each region has a much more specific knowledge where they are operating, whether it be Northern California or Alaska or Washington, wherever these other network operators are. Thing that people might not think about is I think that there's an opportunity to think about how to improve the permitting process of how we deploy these stations, because we have to deal across multiple agencies, whether it's agriculture, interior, and how do we set up a more standardized form instead of having it be regionalized by each district or national forest or national park. Figure out a methodology to make that more efficient or make less friction in the process. I think shared resources between agencies be encouraged. For example, if seismic site is permitted and has telemetry, why not add to this investment by adding other sensors, such as meteorological sensors that can be used by the National Weather Service, or another project I'm involved with, wildfire cameras, and when you're in places that can provide information in those situations. I would recommend that the Alaska TA be integrated into the Alaska Earthquake Center operations and the ANSS, maybe using some partnership with NASA and with NOAA. There's some opportunities there that might be useful because the data are used in multiple agencies. And finally, I'd like to echo the recommendation of the Scientific Earthquake Studies Advisory Committee, and that keeping equal amounts of resources for research as well as towards the network operations. In closing, I'd like to thank the committee for the opportunity to testify on the review of the Federal National Earthquake Hazard Reduction Program, and say the hazard and risk reduction is more important now than ever before, considering how much we've built up our environment.
And Dr. Poland. Mr. Poland. Mr. Robacher, Mr. Tocano, and Mr. McNary, thank you very much for the opportunity to speak here today on behalf of the American Society of Civil Engineers. My name is Chris Poland. I'm a licensed civil and structural engineer with over 40 years of experience in professional practice in structural engineering and earthquake engineering. I'm the NIST Community Resilience Fellow, and my testimony today represents the interests also of the Earthquake Engineering Research Institute. NEHRP, now embodied in the public law, remains a solid foundation for the continued advancement of seismic safety and resilience for the nation. Over the past 40 years, the program has sponsored extensive research addressing all facets of earthquake science and engineering. Its fundamental strength rests in its longevity, continuous funding, and the cooperative efforts of the 4 NEHRP agencies. As both a leader within the NEHRP program and a consumer of the information in my engineering practice, I can say without reservation that the program is a success, fulfills a critical need, and has made great strides in advancing the science and engineering related to earthquakes. For example, the NEHRP development of a technically complex retrofit standard for existing buildings has reduced the cost of implementing California's 30-year hospital retrofit program by billions of dollars. The money is saved by the buildings that don't need to be retrofit and the amount of retrofit that needs to be done. It's a huge, huge contribution. The nation continues to be significantly better prepared to deal with the impact of strong earthquakes, and the program needs to continue pursuing all of its activities. Unfortunately, the program has not yet accomplished all that it was envisioned to do due to chronic underfunding of the 4 NEHRP agencies. The program has also not been reauthorized since 2004, and the annual appropriations for many years have equaled less than 1/3 of the needed $306 million annually recommended by the National Research Council. Together, the lack of sufficient funding and reauthorization have weakened the program's overall effectiveness. This comes at a time when the nation's earthquake risk continues to grow due to the population growth, urban development, and deteriorating conditions of the built environment. What do you need to do? We need to provide more funding.
Since the last reauthorization, the focus of the earthquake engineering has broadened from concentrating on design and construction of individual buildings and infrastructure to also include an assessment of what is needed to make communities more resilient. It has given them the ability to rapidly recover from severe seismic shocks. This broadens the focus and the challenges that NEHRP faces, and it needs to expand its research programs in all areas. Congress needs to signal their support in broadening NEHRP to address community resilience and provide sufficient additional authorization for funding in the following 4 areas. First, identify the existing gaps in seismic safety and community resilience through a nationwide risk assessment. A fundamental assessment of the nation's earthquake risk reduction will refine the direction the program is going, stimulate collaborative efforts between the agencies, establish the needed funding levels and the need for additional statutory responsibilities. This is important after 40 years to really understand where we are today. Second, develop community-based seismic hazard maps defining potential for strong shaking, faulting, landslides, and liquefaction on a block-by-block community scale. These are microzonation maps that we need. These maps are needed immediately, will require significant new scientific research, and are best developed at a national level by USGS to assure consistency and use of latest scientific findings. We've got to have this block-by-block information to overlay with all the other information communities have so they can understand what their needs are for community resilience. Third, complete the Advanced National Seismic System Monitoring Network for recording earthquakes and issuing early warnings throughout the nation. All earthquake professions use information derived from the seismic monitoring, and the emergency management community will eventually use early warning to save lives, reduce damage, economic disruption, and business downtime, and to reduce psychological trauma. Monitoring provides information that we all use, and it's extremely important. When we don't complete the ANSS program, we deny ourselves the opportunity to learn from the earthquakes as they occur. Earthquake warning is an extremely exciting opportunity. It comes with the ability to gather all this information that we need from earthquakes. It needs to be completed, and not in 20 years. Development of a new generation of seismic standards for new and existing construction of buildings and lifeline infrastructure systems is the 4th key aspect. FEMA and NIST should lead the development of a functional, recovery-based design and planning codes from within a reauthorized NEHRP. It should be based on the work of a committee of experts who will set the appropriate hazard levels and performance goals for all buildings and lifeline infrastructure systems, consistent with the Community Resilience Planning Guide for Buildings and Infrastructure Systems, published by NIST in May of 2016. A rating system for easily identifying and publishing the anticipated seismic performance of individual buildings should also be developed and implemented. It's a new generation code that we need, and it takes a fresh start to get there. Fortunately, the current bipartisan Senate Bill S-1768, the National Earthquake Hazard Reduction Program Reauthorization Act, includes these critical additions to NEHRP. Thank you so much for the opportunity to share my views with the committee, from the trenches, if you will. We're down where the people are, where the buildings are. Regarding NEHRP, I urge Congress to move quickly to reauthorize this critical program with these outlined improvements, and I'm happy to answer any questions that you have.
Well, thank you very much, Mr. Pullman. Now, Mr. Arba, you are recognized.
Thank you. Thank you, and good afternoon, committee members. I am Ryan Arba, the branch chief for the California Governor's Office of Emergency Services Earthquake and Tsunami Program. Thank you for the opportunity to testify today. California is vulnerable to a catastrophic disaster within the lifetimes of most residents, and earthquakes is one of those main threats. In fact, California holds 77% of the annualized earthquake risk, and that's estimated at over $3 billion a year in risk over a 30-year period. And more than 70% of the state's 40 million people reside within 30 miles of a known damaging fault. We've kept some statistics of the earthquake impact over since 1950 and found that there have been over 200 deaths related to earthquakes, 19,000 injuries, and over $8 billion in Cal-OES administered disaster costs with FEMA, of course. So Cal-OES's responsibility includes leading California's efforts to prepare, mitigate, respond, and recover to earthquakes. but we can't do it alone. And the program relies on nonprofit, local, state, and federal partners such as the Federal Emergency Management Agency and the U.S. Geologic Survey in order to meet this mission. So today there are several programs that I'd like to highlight that are supported in part by the NEHRP through the program administered by FEMA. The first is the annual Shakeout event. It's most commonly known as the 1-minute drill to practice drop, cover, and hold on, but also includes other opportunities to practice full-scale disaster preparedness exercises and other preparedness activities. And it's one of our most leveraged activities. In fact, we have over 10 million residents that are registered to participate in this annual event every year. And the program is expanded to include 52 million participants worldwide. And in fact, has been copied in over 60 countries. So another thing Cal OES does is we have 3 seismic catastrophic plans focused on the Cascadia subduction zone, which covers the northern 3 counties of California and goes up through Oregon and Washington. And we also have catastrophic earthquake plans for the Bay Area and Southern California. The work done through NEHRP to develop risk assessments for the state, done by our partners at the U.S. Geologic Survey as well as the California Geologic Survey, are supported through NEHRP. And it's that critical component of knowing what the risk is which allows our emergency managers to prepare for that eventual day when the earthquake strikes and we need to respond immediately. Most recently, the Haywire scenario was released, which was a hypothetical magnitude 7.0 in the Bay Area on the Hayward Fault at approximately 4:20 in the afternoon. And the information that's being drawn from this scenario helps emergency managers not only look at the impact to human life and basic infrastructure, but also look at many of our intertwined infrastructure such as utilities, and also takes a look at the impact it could have on Silicon Valley, which not only has a great impact in the Bay Area, but also the world. So, and finally, California is investing heavily in earthquake early warning, a topic that I've heard mentioned previously today, which can provide seconds to tens of seconds of advanced warning. And in particular, the NEHRP program through FEMA, we're funding some research in order to come up with a common tone and alert message and such, so we can ensure that when those earthquake early warning alerts come out, that people are taking the appropriate protective actions to reduce our risk in the state. So reauthorizing NEHRP is critical to ensure that California and the nation are ready for the next damaging earthquake. And I urge the committee to consider the following recommendations. First, reauthorize NEHRP with an emphasis on implementation by state emergency management agencies. And one way to increase that would be through state emergency management representation on the NEHRP Advisory Committee on Earthquake Hazard Reduction. And also, I'd urge the committee to consider expanding the research category known as applied research, which would allow emergency management agencies and social scientists to evaluate the effectiveness of protective action campaigns, for example, and adjust as necessary over time. So in conclusion, California is at great risk for a large damaging earthquake, likely to impact a large percentage of our population, and NEHRP is a critical component of California's earthquake mitigation strategy. Thank you again for the opportunity to testify.
Well, thank you very much for your testimony. Thank you for the testimony of all of our witnesses. And I will assume the first responsibility of having 5 minutes to ask you some questions. We're going to have a little dialogue here.
Mr. Chairman, may I ask a question first?
Yes.
How many rounds? Are we expecting more than one round of questions?
You know what? If we've got time, we will do exactly that.
All right,
we do have to be out of here at 4 o'clock.
Yep, so we've got an hour.
How much time is it?
It's almost 3.
It's almost 3. So we have an hour. And we will use that time, if you so choose. Okay. But it's my time. But my time's running out now. All right. Listen, I want to get a little better understanding on the record here of the type of threat, of the magnitude of the threat that ordinary people in our area, in our state, are facing. I noted that the statistics were that there's a 6.7 earthquake. There's a 99% chance of having one of these in the next 30 years. What is a 6.7 earthquake. What is that? What was in San Francisco was leveled? What what magnitude earthquake was that, etc.? Anyone want to tell me? Go
Yeah,
ahead.
I'll start with that. So the 6.7 earthquake is the equivalent magnitude to the Northridge earthquake. The Northridge earthquake, which occurred in the LA Basin in 1994 and caused a great deal of damage, tens of billions of dollars of damage. The reason that the 6.7 threshold is used is because that is sort of represents the kind of damage done by a Northridge type earthquake, either in the LA Basin or in San Francisco.
All right, and what about, it says also that we have almost a 50-50 chance to have a 7.5 earthquake. How much greater is 7.5 than 6.7?
Well, it's a lot greater, of course. It's greater in terms of ground motions and damage, and also in terms of extent, because a large earthquake like that essentially unzips a longer piece of the fault, and so the more the fault you unzip, essentially in an earthquake, the more area is impacted.
Well,
So as the earthquake
specific on that. With a 7, we know that there was some freeway damage when we had the Northridge earthquake. I remember that very well. But for a 7.5 earthquake, which is a 50-50 chance, according to what we've been told, would the freeways remain operative? Would our water systems remain operative? Would our airports remain operative? And how about the electric system? Would those fundamentals for our society to function, would they be taken out of service by this?
That may be a question for someone else on the panel. It depends on where.
Dr. Poland,
Dr. Poland, not Mr. Poland, but
Mr. Poland has an answer to that.
Let me speak generally about it. A magnitude 6.7 earthquake, like the Northridge earthquake, causes a significant amount of damage. It will not cause a lot of building collapses, even with the most vulnerable kinds of construction that we have.
Right.
It causes a considerable amount of destruction, and depending on the area that it's in, a community may be able to recover fairly well, because depending on if they have all the resources that they need.
What about the 7.5?
7.5 earthquake is a different animal. It is extremely large. It's at the level that we're designing buildings and transportation systems for. It's not the largest that we expect, but it's at the level that we're designing for. And right now our building codes are basically designing the buildings and systems to be safe. That means that people are going to be able to be safe if they're inside and get out and be out until the buildings are repaired. Now that takes care of the buildings that have been built since about 1980 or 85. Buildings that were built before 1980 or 85, about 50% of them are not going to be usable. They're probably going to need to be replaced. 10 to 15% are going to collapse and kill people. And this is in a magnitude 7.5. And all the research that we do and all the work that we do helps us understand how to fix that problem. But the problem sits with the existing buildings and infrastructure systems, and money is needed to rebuild those systems.
Let me go down the list. Will the freeways stay up?
The freeways in California will likely stay up because since 1971 we've been working on our freeways.
Okay, what about the electric system?
Depending on the electric system provider, the electric providers have been working on that, and I can't speak expertly about
the water system.
Water systems are highly vulnerable because they are dispersed across a large area. They cross liquefaction areas, they cross fault zones, they cross landslide zones, and all those things have really not been taken into account in the traditional design.
We get the message. How about the airports?
Airports, it depends on where they are. It depends on whether they're sitting on landfill and they're going to be subject to liquefaction or not.
Mm-hmm. All right, well, and 7.5, that's 50-50. We're told the next 30 years you've got 50-50. Well, that magnitude of earthquake, what's the possibility that we might have something even more damaging than that, even greater than that? Is that
the way structural engineers talk about this, and this is one of the issues we have about getting everybody to collaborate, is we need to talk the same language. And the community resilience work will give us that. But structural engineers designed their building with basically a 500-year return event, and a 2,500-year event is the larger event that we're expecting. And it can be up to 50% stronger. And like was said here, it covers a larger area.
And I've already taken too much time. Yes, we will have another round. Representing.
Thank you, Mr. Chairman. I want to spend a little time on building codes. And Mr. Poland and Dr. McCabe, the National Institute of Building Sciences recently released its 2017 interim report, which found that for every $1 spent on hazard mitigation, the nation saves $6 in disaster costs. What impact should this report's finding have on earthquake mitigation investments?
I think the answer is that NEHRP needs to be reauthorized very clearly, and that we need to continue the work. Having buildings and infrastructure that perform well and don't require significant cleanup and rebuilding is essential to keeping people in their homes, keeping the economy functioning, and minimizing disruption. The previous version of the earlier study by NIBS, the number was about $4. So the numbers are self-explanatory. Investing in mitigation pays off. If you invest in improving your building performance for an earthquake, if you're in areas where high winds may be expected, it will likely do better with that. A water system that is improved in terms of its earthquake performance likely will be more reliable just in normal service. So the investments pay off over time. And in an area in Washington, D.C. where there are significant issues with water supplies, as in other areas in the country where there are older systems, these newer systems perform substantially better. And so investing is an important tactic in keeping the economic health of the country and to avoid having significant disruptions that cause resilience problems.
Thank you so much for the answer. And we're talking specifically about building codes. We're talking about examining building codes going forward, so that all future construction conforms to adequate building codes, and to look at retrofitting existing buildings or rebuilding them completely. Mr. Poland, do you want to respond?
I would like to add to what Dr. McCabe said, and with regard to existing buildings, we don't need all the buildings in the built environment to be able to be used immediately after an earthquake. It's not necessary. There are certain types of buildings that we need within a few hours. Hospitals, police stations, those sorts of things have to be available to manage the response and take care of the injured. Another set of buildings where people live and their local neighborhoods, those need to come back to life. But we have 2 or 3 weeks to get that to happen. We have time to do some repair work. The basic economic engine of a community and its business environment and all of that, there's more time available to do that. We've got to get the workforce taken care of first. The reason I say that is that when we look into the existing building environment, we can design and retrofit those buildings to different levels. And this is what performance-based engineering allows us to do. This is what setting the performance goals that the Community Resilience Guide from NIST talks about. When we go about doing that, the new generation of code will recognize what needs to be done so our communities can take the resources that they have and apply them to the areas that are most needed as they plan their recovery process.
So I get what you're saying about a sort of triaging,
yes,
prioritizing what buildings that we must make sure are resilient. What about multi-family or dense residential buildings? I understand that in many parts of California there's a social justice concern about poorer people or lower income people occupying buildings that may be less earthquake resilient. What thoughts do you have, either of you have, on this topic?
Well, let me just say first, and then maybe you'd like to talk about that. in my mind, the key issue is to be able to maintain your workforce. This is something that was very important in San Francisco as I worked on their program. You need people to stay in the city, be able to get back in their homes and get back to their life so they can go back to work. If they don't, they leave. And if they go someplace else, you can't restore your economy. So that's the key aspect. Now, when you go to recognizing where the key vulnerabilities are, you're going to find that the folks that are economically disadvantaged, the folks that you're talking about, are the ones that are living in the most dangerous buildings, and they have the least ability to help pay for that. And so the issue is, how do we make sure that we need those people for the workforce? How do we make sure that those retrofit work can be done, it can be paid for, it becomes part of a community obligation to protect their workforce? That has to be taken care of.
My time is running out, so it has elapsed. I think the chairman's kindly shown. I know we'll have time to return to explore this further, so I will yield to my colleague, to yield back to the chairman.
Yeah, thank you, and Mr. McCurdy.
Well, I thank the chairman. I think the panel, I think your testimony has been very informative so far. As we've seen with recent natural hazards, it's clearly imperative for lifelines such as utility lines, water systems, transportation systems to withstand hazards and to be put back online as soon as possible, and that strong standards are a very important part of making sure that that's the case. So my question is this, for Mr. Poland, if you can answer it, are there any codes that apply to underground water conveyance tunnels?
When you think about codes, most of us often think about building codes. There's a building department, it's a set of rules that you have to go by to get your permit. When you go to infrastructure systems and water systems, there's no building department. There are various agencies that regulate the design and construction, but most of the time, water infrastructure providers set their own standards for what they're going to design to based on what they perceive is necessary for their community, what they believe they can afford to do within the rate structures that they have to live with, and what their community is saying is important to them. What we have learned, and this is published, that our infrastructure systems are designed to a very uneven level of performance and safety, and in fact, they're mostly designed for day-to-day operations, for normal conditions, with very little regard to the high consequence, low probability events like earthquakes.
Well, I mean, what I hear you saying is that there really aren't any codes, standard codes, really, that could be used in those. So would it be safe to say that large water conveyance tunnel plan, the governor's plan, is not resting on sound geoscience to prevent significant risk?
No, I wouldn't say that. One of the nice things is, I believe, is when you have a project like that, the kind of effort that goes into it and recognition of what the hazards are, the special studies are done, and I assume that these have been done, and that the protection is going to be in place. I would not draw that conclusion from what I just said. Most water districts and communities are small. They serve a small area, they're localized, and they are subject to the kind of discussion that I just made.
Thank you. That's a question that's very important to me in my district.
Right.
How safe are those plans? And recent studies I've heard, a testimony that was taking place in San Joaquin County, showed that there wasn't a set of standards that would be reliable in terms of designing large tunnels for big conveyance projects that cross a large region of space. And
I don't want to disagree with that, and I don't want you to interpret my comments as disagreeing. Those standards are particular to that particular style of construction. I'm not familiar with those at all. But I would like to believe that because of the dependence on that water, people downstream, Southern California and the Central Valley, that we're not going to be able to overlook the consequence of a major earthquake. That has to be built into the system.
Thank you. The U.S. GS produces and updates, still Mr. Poland, national seismic hazard maps. How will developing community seismic standard maps help communities across the nation prepare for earthquake risk?
What we have now from USGS, which is extremely helpful, is an ability for every location within a city to determine what the strong motion is. And they can produce maps for us that show us the contours across a city. That's great for the shaking level, how sharp it shakes. We don't have those kind of maps universally for areas that are subject to liquefaction. And when you talk about utility systems, and your utility system run out across your whole community. You've got to know where the liquefaction is going to occur if you want to understand what's going to happen to your utility systems. The same thing with faulting and landsliding. There are targeted areas, very dense urban areas where some of this information is available, but it's really available for, it needs to be available for any community that wants to understand their resilience.
Okay, has my time expired?
Got a minute.
All right.
Oh, another minute?
Oh, yeah.
Oh,
yeah,
boy.
full more.
I'm going to use it. Mr. Poland, you mentioned that there's a chronic underfunding of developing standards and so on for the United States. How do we compare in terms of having standards to other countries around the world? I mean, are we behind, are we ahead, or we're in the middle of the pack? How do we stand?
Depends on which areas. In third world countries, they don't have any standards. In countries comparable to ours, there are a wide variety of standards. I've never done a study myself to compare those. I know there are international forums that we get together and we talk about each other's standards. I think the most important part is that it's not how we compare to our neighbors. It really depends on how is our built environment going to perform, and is it going to meet our expectations, or is it going to surprise us? And we're going to be caught with a built environment that's not going to serve us very well.
Okay, thank you, Mr. Chairman. Will you go back?
How do we compare in terms of the danger that we face as compared to other countries? I mean, I remember reading accounts just in San Sebastian in Spain, that they had a huge earthquake there. And is Europe still, where do they compare to us? Where do we compare to other countries? Japan seems to be going through a number of earthquakes. So the risk to our country as compared to other countries, where would you put it?
Depends on where you are. If you're along the Ring of Fire, Japan, New Zealand in particular, have significant risk all the way up the west coast of the Americas. That's all part of that Pacific Plate juncture. Interestingly, in Chile, they use their building codes are based on U.S. building codes in large part, and they've had significant, strong shaking down there, and their buildings have done quite well. This the latest one was in 2010, and so we have anecdotal information from actual application of our building codes, but it's a significant risk.
So this ring of fire that we're talking about, does that mean that we, all these countries that are around that edge of the Pacific, are at the maximum risk in the world of having earthquakes and these types of...
I'll defer to my seismology colleague here.
So the Ring of Fire countries obviously have a lot of risk.
You got to try a little bit in your mic.
Sorry, the Ring of Fire countries obviously have a lot of risk, and we share information with those countries. For example, we learn about how to model or understand great subduction zone earthquakes by looking at earthquakes in Chile and Japan. But however, if you look at other countries, like India, for example, countries in the Himalayas, and also Iran, Iraq, other countries, Italy, they face a great deal of hazard from smaller faults, not as dramatic as the Ring of Fire. But at the end of the day, a lot of other countries suffer because their building codes are not as good as ours, and their enforcement of their building codes, if they have them, are not as good as ours. And that was mentioned earlier. The same earthquake in a place with a good building code like ours will do a lot less damage than it would in a country without an adequate building code. So the hazard is really, the risk is spread around the country. I'm sorry,
I understand, that's a good point, and that has been made today. We hear that we really need to make sure that you can't stop the earthquake, but we can be prepared for it. And we thank you. I'm a Boy Scout. Be prepared. I'm a Boy Scout, right? But let me ask you this: in terms of actual understanding the threat, I'd like to ask you a little bit about prediction and warnings. Does it make sense for us to have sensors in space, satellite sensors earthquake security oversees that type of activity. Sensors that might be able to determine pressure building or movements of smaller movements of the earth. Does that make sense for us to be doing that?
Well, certainly monitoring from space does play an extremely important role in keeping track of deformation of the Earth. For example, synthetic radar images taken from satellites. That's very important for mapping out hazards, where the faults are being loaded the most rapidly when an earthquake occurs, how does the crust respond. But we really cannot do short-term prediction from space. We can't really do short-term prediction at all. We thought it was easier before, and by short-term I mean predicting that there's going to be an earthquake of a particular size in a particular place tomorrow or the week after. When NEHRP was first authorized, we were more optimistic about that. We now know that earthquakes are much more complicated than that. Earthquakes basically start small. Some of them decide to grow big, but most of them stay small. And the ones that become big, they start very deep. So it's very hard to see the signals associated with the nucleation or initiation of an earthquake close enough to tell whether you could even predict an earthquake at all at that level.
Well, if we end up predicting an earthquake and say within the next 5 days there'll be an earthquake, so they come back on the 6th day and then you have the earthquake on the 10th day. So I think we're facing that kind of thing. So what our efforts should be, instead of providing warning, we should focus on what comes next to make sure that, number one, beforehand we're prepared. Number two is what we do after the earthquake has come to mitigate that.
And this is exactly where early warning comes in.
Yes.
Because early warning is not early warning of an earthquake, it's early warning of shaking from an earthquake that has already started. So once the earthquake starts, you don't have to predict it anymore. You just need to have sensors very close to the starting point. You can pick that vibration up, you can see how big the earthquake was, how much the shaking is going to be, and you broadcast that out as fast as you can. So the emphasis is shifting, of course, away from earthquake prediction, because that's not going to save lives and property, but warning about shaking from an earthquake that already has started will, as well as increasing the strength of the built environment. So yeah.
All right, my time is up again, and
Well, Mr. Chairman, I'm confident we're going to get through all these questions because we're taking turns and playing nice. So, Mr. Paul, I just want to continue my question I left off with. It was interesting what you were saying. So, interesting to me what you were saying. We have to focus in the aftermath of a major earthquake on preserving our workforce, because that's going to be key to rebuilding. And a large part of our workforce are going to be coming from the lower income folks that are going to do the rebuilding. And a lot of these low income people live in our most vulnerable areas. Can you define, and I recall from this latest earthquake in Mexico City that we saw the tall buildings actually did okay, but it was these mid-sized buildings that didn't do so well. Can you maybe describe what the risks are in these low-income areas and just paint that picture more fully for us?
I think the experience that we saw in Mexico City had more to do with the time that the buildings were built and the quality of the construction that went into building the buildings. And it didn't really have as much to do with the height or not the height. So just to say that. We do know that there are classes of buildings that are they're extremely vulnerable. Unreinforced masonry buildings, the wood frame buildings with soft first story, we call them the soft first story buildings, are open at the bottom, so there's a real weakness down there. And the older concrete buildings that don't have shear walls. Now, when you walked into this building, you probably noticed the diagonal braces on this building. Those braces were put in there to supplement the strength of this building, because it was an older concrete building. It didn't have enough strength to be able to resist the lateral loads. So they put braces in to hold the building up so they would be able to perform. That's good. The point that I want to make is that the older buildings that we have, because they're older, don't have the features, don't have the same quality, and so they tend to be the ones that are more affordable for folks to be able to live in. And those are the buildings that's why they're the most vulnerable buildings. Now, in order to correct that, and where the NEHRP program comes in, is there's a huge amount of research and activity that needs to go in to understand about just how much we need to fix the buildings. You know, an engineer given a task will solve it. I might spend 3 times as much money as I need to, but I'm not sure because I don't have all the information that I need. So we do the research, we figure out the programs, we do the testing, and I can identify through analysis, I can identify what actually needs to be done. And the less I have to spend on each building, when a community looks at this, the more buildings that we can fix.
So, Mr. Pullman, so we don't want to overspend, right? And I wish we had an economist who is also here with us, because part of this problem we have, this conundrum, is the cost of retrofitting, or the cost of just rebuilding. We think that retrofitting is not enough. Was it you, Mr. McCabe, that was talking about a block-by-block analysis, or was that somebody else? You were talking about block-by-block, right? That seems awfully tedious, but is that something we can do, and is that something that's worth the money? And tell me more about that.
Well, I think it's worth the money. We can't go block by block and do the kind of detailed evaluation by the design professionals that I'm accustomed to doing for my projects. You're right, that's way too much. But let's start with the ground shaking and liquefaction potential. As the science develops and the understanding of what's going on underneath the ground, I'm talking like a structural engineer now, what's going on down there, what the vulnerabilities are, that information can be extrapolated, and we can get much better information block by block if the science is improved so we can understand. USGS needs to do the research to sort that out. As NIST and Steve McCabe's group does their research and looks at building performance, we can recognize classes of buildings. Right now we categorize 15 different classes of buildings, and our procedures are all built around those things. As we understand how those buildings perform, then all we have to do is identify in a community what class that building is, and it gives us a good measure about how it's going to perform. And so then we can understand where the mitigation needs to be done. So over on the science and research development side, providing new information will allow us to extrapolate to our inventories of buildings so that we can officially figure out what needs to be done.
Do you have any idea of whether the current compromise in the Senate legislation is including resources for this kind of research or not, or how much more would it cost us to do this?
The National Research Council in 2011, at the request of NIST, did a study about what we needed to spend in the NEHRP program over a 20-year period. I mentioned this in my testimony. They came back and said we need to spend $306 million a year for 20 years. And they gave us 18 different line items of things we needed to do and a whole book full of explanation about what needed to be done in order to achieve what I'm talking about. So my answer to you is we need $300 million. I believe the Senate version has like $80 million in it, or $90 million.
My time is up. It's not just by coincidence we're talking about increased need for money. I mean, the chairman, just put that in front of me. So it's just not going to have to be at the same time, right? I read it back.
Mr. McNerney.
Well, I thank the chairman again. I'm going to follow up on your question, Mark. Mr. Pullman, on the block-by-block analysis, wouldn't it tend to get in its own way? I mean, if there's so much data, if there was a big hazard, wouldn't that kind of information just be so massive and so inaccessible that it wouldn't be useful? In fact, it may even cause problems. Do you envision something like that as well?
No, I don't. Let me give you an example. In San Francisco, you've probably heard about this, put in place a program to retrofit their soft first-story buildings. The reason they did, was there a recommendation? A recommendation? Did I get turned off here? Am I talking to you?
Apparently you did. Speak up.
Okay. A recommendation was made that because San Francisco is bounded on 3 sides by water, that if they didn't do something to keep their people in town, able to shelter in place, if you will, that they would leave, and they would never get them back. And the recommendation was that 95% of the people needed to shelter in place. Came back and did some studies and found out that we were at about 50%, and we needed to get to 95%. We could get 25% more people sheltering in place, if we strengthen the soft first-story buildings. So that program was put in place. Now, as we started to work through the details of how much was it really going to accomplish what it needed to accomplish, it became really important to understand how the shaking was going to vary across the city, where the liquefaction was going to occur, where there was landslides. Because if a building's in a landslide area, there's really not much we can do to it economically to make it shelter-in-place capable. If it's in a liquefaction area, it's the same thing. So having the block-by-block information to answer a specific question, how many of those 6,500 buildings are in areas that we can't fix, how many can we fix, is what I'm talking about. We need the information block by block.
All right, thank you. Mr. McCabe, you mentioned that you want to prevent a building from collapsing, an important part of the standard, but also a building having survivability so that it can be reoccupied and reused quickly. Where are we with regard to those kind of standards that allow a building to be reused after an event?
Well, with an existing building that's been designed and built to an older standard, 1950s era standard, the level of performance is going to be less than a newer building, right? It's a function of the age of the building, the type of the building, the level of the shaking, certainly the ground that it's on. A new building properly designed and competently done is going to probably do pretty well, except under great earthquake level shaking.
So for example, that new building you're putting in San Francisco, it's taller than anything else, quite a bit. You would think that would be not only survivable, but would survive intact and allow people to use it the next day.
I wouldn't say that.
Well, the next day is a little.
Yeah, I mean, what the conversation is evolving to is not necessarily a life safety, get out of the building, pat yourself on the back, and you may have to demolish the building question, which is what it was maybe when NEHRP was enacted. We've gotten things refined, we've gotten things improved, the ground motion information, the hazard modeling is improved. We've done a significant improvement in our abilities to design new buildings. What we're doing though is we're evolving the conversation. Chris Poland's talking about shelter in place, keeping people in their communities, keeping the communities able to continue to function. That's an essential part of this whole conversation. So we've met an initial goal here, and we're moving beyond that. And we've done this on our own because it's an important thing to do. We want to keep communities viable. We may not be able to get a building reoccupied immediately, a hospital, a fire station, something like that, certainly. There may be more time required, but as we get better, we ought to be able to shorten those times as well. That's where this immediate occupancy or the functional recovery standard that's being talked about in California comes in.
So what I'm hearing is pointing to a vision where all these agencies working together to make a community livable after an event.
Yes, we're stepping the game up, and it's due to the conversations about resilience. It's about knowing the ground motion hazards better. It's about recognizing that buildings are not stovepipes by themselves, but they're connected via lifelines. Electrical, water, wastewater, all of these things are necessary to keep a community alive. So we've got a broader vision now, which is pretty exciting.
Yes. Okay, I'll yield back, Mr. Chairman.
All right, we have time for one more round if the witnesses have time for one more round for us. Let me just note that I think one of the primary responsibilities of government, especially the federal government in this case, is to make sure that we are prepared for major threats to the overall safety and well-being of the country and the American people. And that includes what we're discussing today, and thank you for your input into that. And that is understanding what threat we face and how should we approach that threat about earthquakes. And there's also, I mean, a threat that I'm very concerned with about asteroids, that an asteroid could appear. No scientist ever told me that, oh no, that will never happen, and that, or it's 1,000 years away. Not one scientist I've talked to would ever be surprised if we didn't find one 5 years away tomorrow. And so we've got people who are warning us about our antibiotics that are being faced with new challenges at the bacterial level. We've got EMP, which is some solar activity could happen and fry our electric system. All of these are challenges that I think it is important for the federal government to, number one, look at, see how much danger there is, and try to at least see what we can do, if nothing else, to mitigate the damage that will be done if we can't stop it altogether. I'm hoping that we would develop a system that could actually take an asteroid and nudge it off of a path far enough out so it would hit the Earth. But then again, we have to know that that might not happen. So with that said, I want to thank all of you for giving us some suggestions today, but it comes down to, in all of these areas, how much money are you going to spend? And Mr. Poland was very clear in his testimony. We got to spend more money. Okay, let me just note that we are spending already $1 trillion a year more than we're taking in. Already. That's without doing these things, without coming to grips in a big way. So what we have when we discuss these issues of the safety of large chunks of our population, we have to understand that if we're serious about that, we have to figure out where the money will come from and what programs will have priority. Does this have priority over other type of programs? I mean, we just voted for a farm program. I voted against it, but I don't know what my colleagues did. But we had an amendment that said how much money we're going to spend, so many millions of dollars promoting beer and wine. America is beer and wine. Now, when you're spending more than $1 trillion a year more than you're taking in, that just means we're going to have to start making priorities in terms of what we're going to spend. And I assume by your testimony today that what you're telling us that there is a serious threat. That's why I came along in the beginning trying to say, how serious is this threat? There is a serious threat that large numbers of our people in our population could be in great danger. And if we focus on this, it will cost a certain amount of money. We can save lives afterwards. So with that said, I would hope that the next time, I am not going to ask you guys or any of our witnesses to say to them what areas we should cut. But let me just suggest that that bit of information as comparing one program to another will help us a lot more than simply telling us what the threat is. And does anyone have any suggestion of how much money we need to spend now? Mr. Poland suggested, what, $400 million? I forget the exact amount.
It was $300 million a year.
$200 million a year. $300 million a year. And is there some other program that you think, that science-based program, that does not measure up to that?
Great question. You're in a whole lot better place to judge that than I am because you see all the programs. We're the experts. We see a program. We recognize that there are things that could be done that are not being done. I know in my practice, for all the thousands of buildings that my staff and I have evaluated and recommended strengthening for, very few, maybe probably less than 20, were ever strengthened because it's too expensive. Why is it too expensive? Well, we don't know everything we could know. Now, if you could invest $300 million a year in a program, and you could create design guides and maps and GIS systems and things, tools that are necessary to activate the money that's available out there to do all this. None of this money is going for bricks and mortar. None of it's going to fix anything. All it's doing is doing the research necessary to provide the refined tools to make this thing affordable and practical, and so that people go ahead and want to do it. And the other thing that I keep noticing is when these hazards occur, when these natural disasters occur, and people haven't taken care of things because they didn't think they could afford it, and they don't have insurance, then you guys are great. You come in, and I hope you do it for us when it happens to my community. You come in with a whole lot of money, and you fix things. And that's great, and that's part of what this program is about, is trying to figure out how to get the cost of that repair bill down, because the federal government is the last stop for repairing things. So it seems to me that the comparison you're asking for, the programs to cut, I have no idea.
Okay.
But I think that we need to have a different view of what this $300 million a year is going to get us.
Well, we do have, just as I say, lurking right there in the background as we're trying to make our decisions is $1 trillion in debt every year more. And so our young people, at some point that will be a huge threat to the well-being, and it might come, I hope we never see it, the type of financial crisis we're setting ourselves up for by not being able to prioritize. But with that said, you have made your case today, I think, very well. And yes, sir, Dr. Hickman.
Yeah, I think those are good questions. We obviously are not in the same position you are, but I look at the Haywire scenario, which was the scenario for losses from a magnitude 7 earthquake on the Hayward Fault. More than $82 billion of damage, 18,000 injuries, 800 fatalities, and then there's fire after that, loss of water, loss of telecommunications, migration of people out of the Bay Area, potential deflation of an economy. And I ask, I mean, obviously you have some tough decisions to make, but I think we need to revitalize the entire NEHRP program. This is a huge problem. And I agree with sheltering in place. We need to look at infrastructure. We need to make sure the water comes in, the roads can come in for rescue personnel, the water can come in to fight fires, and we have a system that is resilient. So people
and strengthening them, as you made the point, actually can make them more effective even before any type of earthquake would happen. Let's just one last question about the threat itself. We see this volcanic activity in Hawaii. Is that a warning sign to us? Is that something that could indicate that there might be some earthquake activity here? So volcanic activity is not in some way related to earthquake activity.
I think this is a question for me. So,
whoever can answer that, right?
So in the case of Hawaii, it's really not connected to the plate boundaries that cause the earthquakes. Hawaii is sitting on top of a hot spot coming up from the mantle. So it's basically being melted from below. And so Hawaii is the end of a chain of mountains that were formed by melting through the crust.
Okay, so it's
all by itself. It makes its little earthquakes. We had a 6.9 earthquake associated with eruptions in Kilauea. That was pretty big. But they're really not part of the same problem we're faced here in California. It's a different problem.
Okay, one of the things, and the last thing, and I'll make sure my colleagues get a chance to ask whatever questions you have. I've been very concerned that we have nuclear energy facilities that in an earthquake, I mean, look what happened in Japan. They were told, this is absolutely safe, there's no way you're going to have any problem with this, and then look what's happened in Japan. Just very quickly, are you confident? No, well, number one, let me just note, we can build a next generation of nuclear power. We are capable of that. We haven't done it yet, that I know would be safe. But currently, with these light water reactors, which I think are inherently dangerous, are we safe now if there's an earthquake that we could not, maybe, is that a part of this threat? And just very quickly, if I go down the line.
What do you mean? Is it part of the earthquake threat?
I do think that our current nuclear power plants can withstand a 7.5 earthquake and not leak radioactivity.
Well, the U.S. nuclear regulatory, and I started out in the nuclear business, but I haven't been in that for quite a while. The U.S. Nuclear Regulatory Commission has each plant site do an in-depth seismology survey, and so each individual plant is cited and is designed based on the risk that exists for that particular location.
Okay, let me ask you this.
Yeah.
Where's San Onofre on the fault line here? Is it on the fault line?
No, it's off.
Yeah.
Where's San Onofre, down here?
Yeah.
Okay,
Yeah.
well, doesn't look that far away from the fault line to me.
I would, if I were living in Southern California, I would have less concern about that because of all of the attention of all of the engineers and all the regulators at the state and federal level. I would have less concern about that than I would about perhaps other things that are out there.
Well,
Risk is relative.
well, it is, and however, if that happens to go down, we're talking about millions of people being radiated as compared to some people who maybe thousands of people losing their lives in unstructured buildings. And also, of course, I think that all the experts, as I say, just guaranteed the Japanese that there's just no possibility ever if you just put, and what I think is very damaging or just outrageous is we're still trying to sell light water reactors to different countries in the world, and they are inherently dangerous. And we have the technology capabilities to build safer nuclear reactors, and we should. But anyways, do we also comment on?
I just want to add to what Dr. McCabe said. I think that it's important not to compare buildings that were built without any consideration for seismic, no design, like unreinforced masonry brick buildings. With a nuclear power plant, even if it was designed and constructed 30 years ago, that was given an extraordinary amount of consideration, design, analysis by the best experts that we had because of the very threat that you're talking about. One of the things that we saw in Japan, I believe, is we had a black swan of event. We had an event that nobody thought was going to happen. Or at least the consensus of the community was that event was not going to happen. The wave wasn't going to be that high. We weren't going to experience that. Okay. So that's, to me, that's I don't think it's proper. Maybe I shouldn't say that. I think we have to recognize that that event was something completely out of the order of the expectation. But the main point I want to make is not to draw conclusions from very poorly built buildings. That's something that has been designed deliberately in a very careful process.
Well, they're two different threats, and I will just have to say that I personally have been disturbed that we have not developed the next generation of nuclear power, which we know we can do, that would not leave us as the current system.
Thank you, Mr. Chairman. Mr. Paul, this $300 billion figure that you...
300 million.
300 million.
Million.
Gosh,
You guys always say billion. We built to say billion.
I was thinking 300 billion.
Oh no.
So 300 million, that's...
We could fix all the buildings right now.
We could fix all of them. But that makes more sense. $300 million, which is not bricks and mortar, but which is about research, which is about information. And the picture I'm getting from you is it would help us understand what buildings that were built in a liquefaction area that would make little sense to invest a lot in retrofitting, but that information that the federal government would provide to the local planners would, and the building codes would say, if you're going to build in areas of liquefaction going forward, you better build this standard or not build there, or just discourage building there from, at all.
Or accept the consequence. Yeah.
Well, and also, I would assume, bring the market into this, because insurance companies who insure, underwrite earthquake insurance would be able to use this information also and price their policies accordingly.
That's
Right?
correct.
So there would be also, it would be government data that would also inform other kind of market incentives to be able to drive us in the right direction. Mr. Vernon, you have something to say about this?
One other aspect of that $300 million per year, it also fully fills out the advanced national seismic system. So not only the research component that you talked about, it also gives us the seismic network monitoring capability that has been fully planned for. So that's another component of that $300 million a year.
Yeah, it's not all the block by block analysis. I mean, there's that $300 million.
No, that's one
One piece of it. One piece of it. Well, this has been a very fascinating hearing. I want to understand now. Is this research the conclusions you've drawn about what people would do if they couldn't shelter in place? Is that part of the social science that needs to be done? Would you say? I understand there's a social science aspect to responding to earthquake disasters.
Yeah, that certainly sounds like an opportunity for that. I think a lot of the focus on the social sciences, especially in the current environment with the focus on earthquake early warning, is how to best utilize that alert. But that's certainly an opportunity that could be pursued with the specific dedicated.
Go ahead, Mr. Paul.
Let me just add one thing. The NIST Community Resilience Planning Guide, which is kind of the framework for this new generation of building codes and this new generation of thinking about how we want things to perform, starts by understanding what the social institutions are, and that's working with social scientists, and then prioritizes which of those social institution products and economic products are necessary at what time, and then how those are supported by the built environment. That's how the performance goals are developed. So that's something we've never done before, in my mind, is turn to the social science community and have them help us to understand what people need, how they're going to respond, and what communities are in order to efficiently recover.
So, Mr. Owen, I understand that San Francisco and Los Angeles have undertaken major initiatives as described by Mr. McCabe, the ordinances they passed, the commitment to look at what buildings need to be retrofitted, and there's a social justice element to how these ordinances were also designed. I understand the California legislature is moving forward with some of its plans. How is it that we can make sure that this reauthorization works in tandem and helps leverage what California is doing, and how can the federal government be of the best assistance to the state of California?
Yeah, I mean, it's certainly as these policy issues advance, as part of Cal OES and working with our partners, we're often looking to that research in order to make the decisions that we have to make on these separate considerations. So it's, I would just say, consistent with what was said earlier about continuing to make sure that among all of the different research topics that we have that's covered in the NEHRP program, that a specific emphasis is called out for research, as mentioned.
I'll just add that we believe that the social science aspects, the policy aspects, are very, very important. We've brought on social science expertise at NIST to help in this process, because it all has to do with accepting the risk, making decisions about the risk, ultimately engaging in programs that will make things better. This is a very grassroots kind of thing, but you're talking about a community surviving and potentially flourishing. So it's not just the engineering, and that's a big part of this going forward.
Well, so the seismic hazard maps. Go ahead, Mr. Hickman.
Yeah, I was going to add, maybe that's where you're heading with your question. Getting the more kind of resolution, the high resolution pictures we need for seismic hazard in urban areas is something that people have done in Seattle, Los Angeles, but we need to do more of that. So urban seismic hazard mapping is one way to produce a very high resolution picture, not quite block by block, but close, of how the ground is going to shake during an earthquake, using realistic models for how the sediments focus the energy, where the faults are, how the faults might break. And so it's important to think about the science too, because your liquefaction models depend upon the ground shaking models, because it's ground shaking that causes liquefaction. So when you think about this, think about the integrated package that involves the engineering, but also the earth science that feeds into that, and the social science that can control so people respond. And I think that's the beauty of NEHRP, is we all work together on these problems. We're already working very closely with Cal OES on earthquake early warning, for example. So I just like to see this sort of horizontal building of these kind of models that depend on solid science, really good engineering, and then the social science to make sure that people know what to do with the information they have.
Yeah, I was going that direction with the seismic maps, that we need, that's going to be very useful for city planners, for insurance companies. I think we can more information will help. The market can also help us, help guide us in the right direction as well. But I think the public needs to understand the risks and where the liabilities are in a community. How are we going to address the low-income folks that are living in the riskiest areas that constitute our important workforce? And we are a great economy. Depending on which statistics, the 5th or 6th largest economy in the world. And what happens to us if we become disabled? And the question is, how disabled? And again, the perfect word, resilience. How do we plan for resilience? So thank you very much. I'm going to yield back my time. This has been a fascinating year.
And Mr.
Well, again, I think the chairman again, and again, I'm going to follow up on Mr. Tacoma's question to Mr. Hickman. You were talking about models that, or how we can model a high enough resolution to be helpful in planning. How advanced are the models that could be used to do that? Is that where an area of research that the $800 million would go to?
Absolutely, that's an area that's needed. More work is needed. We have very sophisticated computer models now. We are missing information, for example, on the structure of sedimentary basins beneath Seattle, beneath Los Angeles, beneath San Francisco. We know from Mexico City that sediments resonate with different earthquakes, and that has big implications for tall buildings and engineering. So we need more information to be able to characterize the geology beneath the big cities that face so much risk. We need more information on characterizing the faults that are along them. How are those faults likely to break based upon their past history? So that means doing more of what we call paleoseismology, looking backward in time to see how faults broke over time. And we need to do more work on seismic wave propagation. How do the earthquake waves coming away from the fault change as they come up to the surface, and how are they modified by the soils? How does that lead to liquefaction? How do landslides occur? There are a lot of unanswered questions, so I think the science will drive a lot of important hazard and risk reduction products.
Would you say that's more empirical science or more computational theory?
It's both. It's both.
Okay.
But we are computational. There are certainly supercomputers churning away right now on these kind of models, but we need more data to feed into those, and we also need more theoretical understanding.
Okay, good. I also want to hear a little bit more about the TAs and the ANSS. How do you say ANSS?
The Advanced National Seismic System.
So, I mean, the TAs, are they flexible geographically, or how does it work? How does the TA work?
It was a project that started in the National Science Foundation and is now pretty much finishing its end of life. It's completing its deployment in Alaska now. What we've left behind is this Central and Eastern U.S. network, which is now part of the ANSS.
What is the TA?
Transportable Array. It's part of the EarthScope program under the National Science Foundation. It was an MREFC, Major Research Equipment Facility.
So what does it mean? There are sensors there?
It's a transportable array. Each station was deployed for about 2 years. There were 400 deployed at a time. You took one off the back on the west coast, you moved more to the east, and they just kept rolling and forward. Each station was in place for about 2 years as we moved across the country. Magically, right about the time in 2007, in 2008, we got into Oklahoma, and right when all the earthquakes started there, happening there, so it's quite a bit of that.
So how do they fit in with the ANSS?
They inform the ANSS in the sense of where the seismicity gives you a snapshot in time. It gives you more information about the structure, like Steve's talking about. We're talking about how do you actually get the amplitudes that you might expect from certain size earthquakes. So it gave us a a data set that we can use to inform some of these models and studies that we're talking about.
So is an ANSS also array, or is it a model?
No, the Advanced National Seismic System is a set of seismometers deployed permanently in the ground throughout the U.S. There's components, big components here in California. There's a Northern California Seismic Network, a Southern California Seismic Network. There's one in Washington. They're integrating them together to do these earthquake early warning systems. There's a big system in Alaska. There's ones in the central U.S. around the New Madrid area.
Can a TA become part of the ANSS?
It could have been if it were left in place, but to say we lost that opportunity. That's what I was trying to say. When we do these large-scale programs, we should be thinking about the longer-term implications, how we can leverage those investments to make more efficient use of the dollars that we do spend on science.
Right.
If I can add, ultimately, if you're going to have an engineer design a building or a lifeline system, we need to know what the threat is, what the seismology is, and particularly in the eastern 2/3 of the country, that data provided by the TA system is invaluable. Rare events like the 2011 Mineral Virginia earthquake revealed the importance of having instruments even in places where you may not expect earthquakes to occur with regularity. But it's important for us to do our job as engineers.
Mr. Chairman, I yield back.
Well, I want to thank our witnesses and I want to thank my two colleagues for joining us. This has been I would say, an enlightening and, it's fun. It was, to be actually transmitting important information and doing so in a way that is interesting. And thank you, witnesses. Thank you very much for coming and sharing your expertise in the way you did. Let me just note that I visited Pompeii with my family. Visited Pompeii. Pompeii was one of the most powerful cities in the world. And it was just people who have not been there should visit Pompeii to see what nature can do overnight. And there you've got this evidence that has been put down and people's bodies are covered with that soot and everything. But what's most important is you had this powerful city and within a day, it no longer really existed. And we know that there are major challenges in nature. I mentioned asteroids as something like that. And we do need to make sure that we do understand that these challenges are there and what we can do about them. And you outlined today what we can do that would perhaps save lives in the long run and making sure that if there is a major earthquake, which there will be in Southern California, that we survive that and that we minimize the suffering that will take place on one of these acts of nature. So you've given us specific actions and specific policies that you said would help deal with that and help us minimize that type of suffering that would result from an earthquake. So let's hope that we can now, we understand the challenge. The biggest challenge is making sure we're responsible enough. If it's only $200 million, not even billions. Usually when people come to us, there's all these billions, right? Well, it's a very reasonable amount, but we have a $1 trillion deficit we've got to deal with. And I would hope that when we look at that issue of $1 trillion that we're spending more than we're taking in, that what you talked about today, I believe a primary responsibility of government, especially the federal government, is to make sure that they protect the safety of the American people, both from a foreign attack, but also by the natural disasters that we're discussing today. So it's our responsibility. Thank you for giving us some insights that will be useful to us. And with that said, Oh, wait a minute. Oh, yeah, okay. The record will remain open for 2 weeks for additional comments and written questions from members. This hearing is now adjourned.